Hey, geometry. We are looking at lesson 2. We're in unit 6, coordinate geometry. And again, you don't have your classwork with you, so I need you to take notes, write down some important things, and the classwork is always available for you in the im.kindlehunt.com website, which I've linked for you in Google Classroom. Okay, now we're doing transformations as functions. We're getting a little more algebra-y. That's not a real word here, but it'll be great. All right, so let's get started. Let me move this up a little bit. Oh, I don't know what I just did. So mentally find the coordinates of the image A under each transformation. So first we're going to translate A by the directed line segment from 0, 0 to 0, 2. If you think about what's moving here, our y value is going from 0 to 2. It's increasing from 0 to 2. So that means that our y value here is probably going to be increasing by 2. So I'm going to say it's going to go 3, 4. So if we think we're going here, 0, 0 to 0, 2, that means this is probably going 3, 4. Yeah. I know it said mentally, sorry. Translate A by the directed line segment from 0, 0 to negative 4, 0. So the x value is changing from 0 to negative 4. So we're going this way. That means my x value is going to change on my A coordinate 2 by a minus 4. 1, 2, 3, yeah. So it's going to end up at negative 1, 2. So only the x coordinate changed in that. How about I reflect across the x-axis? Oops, let's change colors. So I have the x-axis here. I'm reflecting across the x-axis. That means that my x value is probably going to change signs. So it's going to end up right here, which is 3, negative 2. And it's the y value that changes signs. Okay, so that is a x-axis reflection. The y value changes signs. Woohoo! And then rotate 180 degrees clockwise. So 180 degrees clockwise is all the way over. So that means it's going to go from coordinate 1 to coordinate 3. That's coordinate 3. And it's going to end up all the way over where both signs change. Okay, negative 3, negative 2. Pretty cool. These are very important. They weren't difficult once we knew what we were doing, but they're very important. I'm going to move this up a little bit too. For each point xy, find its image. Remember, we have pre-image and image. Image is the final under the transformation. Okay? So we don't have to do anything with the graph yet. We're just changing it using this function, using that function notation. Okay? We're using this function notation for A. Prime is going to be negative 10 plus 12 and 5 minus 2, which equals 2, 3. Okay, B prime, which is the image, not the pre-image, I'm going to have negative 4 plus 12 and 9 minus 2, which gives us 8, 7. And then change colors. C prime, negative 2 plus 12 and 6 minus 2, which will be 10, 4. So that finds the image. And then we're going to sketch triangle ABC and its image on the grid. I'm going to do ABC just in a black color. Negative 10, 5, -4, 9. Sorry, that's really small. And then -2, 6. And that's A, B, C. I'm going to do the image in yellow. 2, 3, 8, 7, and 10, 4. 1, 2, 3, 4. A, B, C. So now it's telling us, or it's asking what transformation is x, y, x plus 12, y minus 2. Well, that's a translation. And we can say it's by a directed line segment. And rather than look at what's happening up there, we can actually just use this here to give our directed line segment. We're going from 0, 0 to 12, -2, just using this for our math. If I plug in 0, 0 for x and y, I get 12 and -2. It's pretty cool, so we don't really have to look at the graph to find the directed line segment. All right, now let's look at each point in the table and find 2x and 2y. So we're just, well, we're going to figure out, we're just doubling it here. So -2, -6, -2, 2, 10, 2, and 10, -6. Okay, now I'm going to push pause and sketch the original figure and the image, the pre-image and the image, okay? So what do we have here? What transformation? If you see, I sketched the pre-image in yellow and the image in black. What does it look like we have? I see a dilation, and it's a dilation with the origin at the center. And it's a dilation of a scale factor, remember those, of 2. Cool. All right, one more. As you can see, this lesson is very graph heavy. If you happen to have graph paper at home, that's fantastic. If you don't, but you have access to a printer, there's lots of graph paper that you can print off. I'm trying to figure out if I want to try to print this stuff out for you guys next time I'm allowed on campus, which is, I think Thursday, but it might be worthwhile to do that and just try to get these packets to you guys, but I'm not sure right now. So here we are. Here are some transformation rules. Apply each rule to the quadrilateral and graph the resulting image. Then describe the transformation. Okay, so we're starting out with that A, B, C, D. And we're going to go with a 2x comma y for the first one. And the second one will be a x comma -y. And the last one, we're actually going to switch our x and y and make the x negative. That one's really interesting. Okay, so the first thing I'm going to do is make a table of A, B, C, D. So there's our pre-image A, B, C, and D. Okay. Let's figure it out. Okay, so first I'm going to take that for A. We'll go in red. I'm going to go 2 times x, y. So it looks like our x values doubled. Let's see what that looks like when we graph it. Pretty cool. It just looks like we have a little bit of stretch, right? We can say it's a horizontal stretch. Because it's along the x-axis by a factor of, you guessed it, 2. All right, let's try the next one in blue. Okay, with this one, if we notice, it's our y value that changed signs, and we ended up with a reflection over the x-axis. Even though it's our y value that changed signs, went from negative to positive. This one is cool, okay? So we're changing our x and our y and making our x negative. So if we look at our values, I flipped the order of the x and the y, and then I made sure that the x's were opposite sign, in this case, all negative. I'm gonna graph it. Isn't that cool? What did we get? Looks like we went, clockwise? Yeah, that looks like it's clockwise. Clockwise rotation. The origin at the center. And that's where we changed our x and y value and made our x negative. Okay, that would be a clockwise rotation with the origin at its center. Cool. That's it for today.